Hello guys, how are you? I hope you all are well. Sir, in this video we will see the NEET previous year questions. So let's go for one question. First question. First question says 2-point charts A and B having plus Q and minus Q respectively are placed at a certain distance apart and force between them is F. So in first three statements he says 2-point charts A and B. A's chart is plus Q and B chart is minus Q. These are placed at a certain distance D, and force between them is F. These are given in the question. Okay. Now in second condition, if 25% of charge of A is transferred to B, that means from A we take 25% charge, I mean 2 by 4. 25%, that means 25 upon 100, that is 1 by 4 charge taken. Okay. Now A have new charge Q minus Q by 4, and this charge Q by 4 goes to the B, and now B's charge is equal to minus Q plus Q by 4. Now new charge of A become, when we take the LCM, 4Q minus Q, that means 3Q by 4. And here take LCM 4 minus 4Q plus Q, minus के 3Q by 4. D is the same. D is distance between those two charges is same. Now find out F dash, new force. Okay. First of all, we find out this value of this force. F, the value of F is equal to K Q into Q upon D square. Many students take the sign. Friends, listen carefully. F is a vector quantity. It has two things. One is magnitudes and other is directions. Magnitudes told about the formulas and direction told about the minds. Which types of minds? Like here is the positive and negative charge. Two different charges attract each other. That means positive and negative attract each other. So these are the directions. And magnitudes is our K Q upon D square. So we can not take sign in this formulas. Okay. So in this formulas we take only magnitude value Q and Q. Now the value of F will be K Q square by D square. Similarly, here we will find the force here. F dash should be K, this charge and this charge, only magnitude value. Okay. So 3Q by 4 and 3Q by 4 upon D square. Now first of all we simplify the numerical values. 3 multiply 3 9 and 4 multiply 4 16. This will be 9 by 16. K, this K, and Q square upon D square. You see carefully that these things K Q square by D square is the value of F. These are F. So we put the F. 9 by 16 F. So now we will get the answer. F dash, the new force, will become 9 by 16 of old force. Okay. So this was the answer. Okay. Now we will come on the next question. Next question is the relation between Q and small q, capital Q and small q, for which the potential at the center of the square, this remains a square. Okay, the potential of the square, the potential at the center of the square is 0. That means he said potential at this point, center point is 0. That means he told VC equal to 0. Let's suppose we know if any charge Q present here, so then the potential difference from R, from this Q is KQ by R. The value of KQ by R. Potential is the scalar quantity. If this charge become negative, then this value become minus KQ by R. Okay. If we know these things, then find the potential by this charge on the center. Okay. So we got V net, and V net given in the question is 0. So first of all, find the potential. The potential of this charge on the center will be minus KQ by R. R Listen carefully. These are the square. These are the square. And diagonal of the square is same. That means the length of this and the length of this same. And they cut the equal. They cut at the middle point. That means this length, this length, this length, and this length. Both lengths are same. Let's suppose we let this length is r. If this length is r, both are similar. Okay, both lengths are similar because the length of both sides will be equal. The whole length will be equal to this length, and the half length will be similar. So potential by this negative charge is minus kq by r. Similarly, potential by this charge on the center is minus k small q by r. Similarly, by 2q, so these are positive charge. So we take the positive sign. 2k small q by r. Similarly, plus 2q kq plus 2 capital Q by r. Okay, is equal to V net. But in the question, V net given is 0. V net is given is 0. 0 equal to, here listen carefully that minus we take capital Q in one bracket and small q in other bracket. So when we solve in these two things, we found kq by r, kq by r. But this is negative and this is positive. So net result is kq by kq by small r. Kq by small r. Similarly, when we solve these two things, so we found also plus k small q by r. K small q by r. Now we take common. Let's suppose k by r take common is equal to q plus small. Goes this quantity to this side and this becomes 0 because these quantities go in the upon of 0, so this will 0. 0 equal to q plus small q. Just simplify q is equal to minus k. Okay, so these are the answer. Okay, now we will go to the next question. Next question is, where do expect the resultant magnetic fields to be 0? That means resultant magnetic field find out by these two conductors. One conductor is this and current going is this. Current going is this. These produce magnetic field. Similarly, other conductor is this. The current going is this direction and find the magnetic field. First of all, we take 4 points. 1 point is here, 1 point is here, 1 point is here, and 1 point here, and find the potential. If 1 point here, this point is similar like every point. If every point you take in this side, anywhere will take any point. So same behavior like this point. Okay. For example, if we will find the magnetic fields by these two conductors and this point will be same. The magnetic field find out by these two conductors also at this point. Okay, so we take only single point. Okay, now how to find magnetic fields? So by magnetic fields find out by the right hand rules. We put the right hand rules like that finger and thumbs make 90-degree angles, and we put the thumbs in current directions, and where finger puts where magnetic field is found. Okay, and curl the finger. If finger is going to downwards direction, so then magnetic field direction is downward. If finger is going to upward direction, so then magnetic field direction is upward. So that how to decide? First of all, we put the thumbs in the current directions, and where magnetic field is found, we put the finger, and after this curl the finger. Finger direction store the magnetic field direction, as like here. Here the current carrying conductor, the current is going upward, we put the thumb upward. Magnetic field points is here, so we put the finger like that. Now curl the finger. We found that the direction is downward, inward. Okay, we find that by this conductor at this point, the magnetic field direction is downward side. Similarly, we find by the help of this. We put thumb in current direction, and magnetic field point is there. So we put in finger. Now curl the finger. We find that current is going outward from this board. That means the direction of magnetic fields is outside. Now listen carefully. listen carefully that there this one is current carrying conductor and current goes current I, and similarly these are current carrying conductor and current is goes I. Similar current, but direction is different of magnetic fields. That means we can say by in this whole portion, by the total the net magnetic fields will be zero, because one current conductor's magnetic field is downward direction and one other current conductor's magnetic field is upward direction. So that means in this portion net V net is equal to 0. Now we study about this point. Okay, this point. First of all, we take this conductor. We put the thumb in the current direction and put the finger in where the magnetic field is find out. Now curl the finger. We found that the magnetic field is outside, and that for that we can say by this conductor at this point the magnetic field is outside. Magnetic field is outside. Okay. Now by this conductor, the current is going this side, and this point is down from this conductor. So we put the finger in downward sides. Now curl the finger is the finger direction is inward side. That means we can say by this conductor in this points the magnetic field direction is inward side. So we can say same current goes, and one is creating its outward side, one is creating its inward side. So we can say B net in this portion will be 0. Okay. So we can say the net current at a net magnetic field at AB at any point, like here, at any point will be 0. Okay. Now our answer will be this or this. First of all, we will check about the CD. Now we will take this point. But and take this conductor. Conductor current direction is upward. We put the finger where magnetic field is found. Put and curl the finger. We understand that our finger is going outward direction. That means current magnetic field will be outward side. Outward side is represented by dotted. Okay. So that means we can say by this conductor at that point magnetic field be outside. Now similarly we find this current carrying conductor. Current is going their side. The thumb we put in their side. Magnetic fields find out at this point. So we put the finger, curl the finger, so that means magnetic field direction is outward direction. So we can say in this conductor and this conductor, this point current magnetic field direction is both outside. So we can these magnetic fields will be add. This will not cancel each other. So that means here in this whole portion, some magnetic field exists. Similarly in this portion, when the current going in this direction, we put the thumb in current directions. These are the downward direction. So we put the fingers in downward side. Now curl the finger. So we find that finger is going the inward direction. Okay, that means going the inward of this plane. Direction will be this one. Now find by the help of this conductor. Current is going upward. So we put the thumb and magnetic field at this point. So we put the finger at this point and curl the finger. We found that the finger will going on inward sides. So that means net magnetic fields is inward. Net magnetic fields it is going to inward directions. So we can say on this point, here some magnetic field exists, here some magnetic field exists. So we can say that means in this line, net magnetic fields never be 0. But this line, on this line, magnetic field will be 0. So we can say the answer is AB. Okay, and on AB, magnetic field will be 0. I think hope so. This are you got my point? Okay. Now, new questions. The mass of the wire of the copper are the ratio is 1:3:5. That means 3 wires is given. How many wires? 3 wires. 3 wires mass ratio. Mass ratio given. Mass ratio is 1:3:5. And next, and their length is the ratio of 5:3:1. Length ratio also given. 5:3:1. Okay. Now the ratio of their electric resistance is the find. That means question asks the ratio of resistance. We know resistance R is equal to R is equal to rho L upon A. Here R is the electric resistance, rho is the resistivity, L is the length of the conductor, and A is the cross section of the area. But in the question given is mass, and in the formula mass is not given. So we convert this formula into mass term. Okay. First of all, we know volume and area's relation. Volume equal to area into length. Area into length. Here if we find area equal to volume upon length. Volume upon length. We put the value of A in this formula. So we put rho L upon volume upon length. Length will go upward. So rho L square upon volume. But these are not also converted in mass form. But we know one other formula is density equal to mass upon volume. If volume is going their side, then mass upon density will be new form of this formulas. Okay. Now we put the value of volume. Rho L square upon mass upon density. Okay. Now density will go to upward direction. Think that net formulas will be rho L square density upon mass. Now we can say our R is dependable L and M. Or how dependable? That we take rho is constant, resistivity is constant, and density is constant. Thus the formula will come R proportionally L square upon M. Now for 3 wires we can take the ratio R1 ratio R2 ratio R3 is equal to L1 का square upon M1 plus ratio L2 का square upon M2 ratio L3 का square upon M3. We put the values and we find out the relation. Okay. How to put here L that means 5 square upon M equal to 1. 5 square upon 1. Here value of L is 3 square ratio 3 square upon M value is also 3. Here value of L is 1. 1 square upon 5. This after simplification this value is come here 25 upon 1 and 3 cancel by power, so 3 upon 1 and 1 upon 5. These are the ratio. A ratio is not take in fractional form. Never take it, because ratio is also fraction. Okay, so we will remove these things. That means we will remove the 5. So we multiply whole things in 5. That means we can say these are this, and we remove 5. 4 remove. We will multiply the whole things by 5. So now after multiplying this become 125 and this become 15, and when this multiplied by 5 by cancel, so this become 1. So this will be the ratio of resistance. The answer is D. So hope so you got my point. Now we will go the next question. Next question is here is this is the image. Let's suppose this consider A, B, C, D. Okay, A, B, C, D. This image, if these are current carrying conductor, okay, these are one current going this here and here and here and here. Okay, look like these currents create a magnetic field on the center. So what is the magnetic field value? Okay, first of all, this is question based on the Biot-Savart. Okay, first of all, we know that if current carrying here, we know if current carrying conductors is this, and if in the path of if anybody asks the magnetic field in the path of current carrying conductor, as like here this conductor going to this point, this conductor is going to cross this point, like here point this conductor is going to cross this point, so that magnetic field value will be 0. That means in current carrying conductors direction, if any point is exists, at where magnetic field value will be 0. That means we can say by this portion goes to this point, and this portion also goes from this point, So we can say no magnetic field by this portion and no magnetic field by this portion. That means if current carrying conductor's path in current carrying conductor's paths, any points have no magnetic fields. Value of B will be 0. B will be 0. So we can say in this current carrying conductors goes through this point. So that means this point goes on her way. So we can say that by this current carrying conductor B naught is equal to 0, and this current carrying conductor go away from this point. So that means by this point we can say net magnetic field will be 0. But these are the two arcs. By these two arcs will also create magnetic fields. First of all, we should know the formula. And similarly like here, B is also a vector quantity, and B has two things. One is magnitude and other is direction. Magnitudes find out by the help of formulas, and direction help by the help of mind. Okay? How? Yes. How? For arc, by arc create magnetic field on the center. This formula is mu naught I upon 2r. Suppose I is this, r is the radius, and this creates the alpha angle. So alpha upon 2 pi. These are the magnetic field value on the center by any r. Okay, man? Okay, sir. Okay. Now come in. Here are two arcs. First radius is A and second radius is B. First we will talk about the magnitudes. Only magnitudes. And next point, after this we will find out the direction. Magnitudes find out by this formula and direction find out by the mind. First of all, we talk about the magnitude. Let's suppose these are represented by 1 and these are represented by 2. Let's suppose 3 point is this and 4 point is this. We know that by the 3 points, by the 3 conductor, by the 4 conductor creates no magnetic field. So first of all, I write B3 equal to 0 and B4 equal to 0. And these R portion and this R portion creates a magnetic field on the center. Okay? We can find out the value of this is by this formula. By this formula, B1 value will be mu naught I. I is the current, mu naught I upon 2 R that is radius. Here given the radius, the value is A, 2A. And angle put on the center is alpha upon 2 pi. Now we will find by this R, we will write B2 because this conductor's name 2. So B2 is equal to mu naught. The current is I upon 2. The radius of this conductor, the radius of this R is equal to B. So 2B. Bracket में alpha upon 2 pi. These are the magnetic field value. Related by these R and these R on the center. Now we told about the direction. Last time I told when we show the third question, so I told you that we put thumb on current direction, then curl the finger, told about the magnetic field. First of all, we put the thumb in the current directions, and where magnetic field is find out, put the finger, and after this curl the finger. Direction of curl the finger will told about the magnetic field. Similarly, here magnetic field told about the finger and current about the thumb. But if we change, if we convert, we use vice versa, then if curl the finger told about the current, first told about the thumb, about the current. Okay. Now if curled fingers told about the current, then magnetic fields told about the thumb. Okay. First times we told that this told about the current, then this told about the magnetic field. Now I told the repeat things. These are told about the current and these are told about the magnetic field. Okay, sir. Okay. Now, sir, here current direction is this. So that B direction will told about the thumb. Current direction is this, that thumb is going outward direction. That means by this arc, magnetic field created by outside. Magnetic field created by outside, and by this current carrying conductor, this arc, by this arc, put the finger in the current direction, put the finger in current direction, and thumb going automatically in downward directions. So we can say this creates magnetic field value is this and direction is this. Now question is net magnetic fields. B net is the sum of B3, B4, B1, B2. These are the value of 0, so we will not consider. But these two things will be considered. Okay. So if we will take these things in outward direction is positive, then we already consider this thing is going to downward direction, and we will take the negative. So B1 minus B2. Okay. So put the this value is here and put the this value here. You think carefully. This one is the all are common things. Let's suppose mu naught I bracket में alpha upon 2 pi upon 2 is a common. So let's suppose these things take in here. This remaining only 1 upon 8. We write 1 upon 8. Here similarly these and these are common and left 1 upon b. If this side we take positive, then we automatically take negative of this side. Okay, sir. So that B net will be mu naught I alpha upon 4 pi bracket में 1 upon a minus 1 upon b. Many students thought B2 minus B1 B net should be B2 minus B1. But sir, listen carefully. A1 is A is less than to B. A is smaller. When divided by same things by A, so this will higher. B is bigger. When bigger things divided by the same things, then B2 value the minus. So B1 minus B2 is the correct answer. Okay. So hope so this will be the answer. I think and direction will be resultant direction is the resultant direction is outward direction. These are the magnitudes and these are the direction. Many times sharp students give answer only and only by the help of directions. Okay. So I think also you got my all points. Thank you and thank you very much.